Today looking at 4.5, equivalent forms of the equation of a quadratic function. So there are two types of equations so far that we're going to look at. One is standard form, and standard form looks like this, where y is equal to a bracket x minus p bracket squared plus q, and general form, it looks like this, y is equal to ax squared plus bx plus c. So we're going to learn how to go from standard to general form, and then from general form to standard form. So read this information there, take a look at how I've done the example, and then down here I want you to try the equation, and then once you've tried it, stop the tape and check it to see if you got the right answer. So you've now tried the tape, so here we're going to switch this standard form into a general form. So here we go, y is equal to 3 times x plus 5, because there's 2, I'm going to write it down twice, minus 6, y is equal to, and I'm going to bring the 3 in, 3x plus 15 bracket x plus 5, because we can only multiply two numbers at a time. 3x times x is equal to 3x squared. 3x times 5 is plus 15x, and then 15 times x is plus 15x, and then 15 times 5 is plus 75 minus 6. I then group my like terms, and like terms have to have the same variable and the same exponent. So x squared, only have one of them. So I'm looking for x, that's it. So 15 plus 15 is 30x. And then here 75 minus 6 is positive 69. So there is my answer to this equation in general form. Once you've done that, then once again I want you to take a look at this equation here, and this equation here now goes from general form to standard form. So see how it's done. It's very important because we're going to bring something in about completing the square. That's very important to learn how to do that. Once you take a look at it, and then once you try this equation by completing the square, and then from there stop the tape and take a look to see how I've done it. So you've now done this. Now they're asking for the vertex and the axis of symmetry. So y is equal to a times x minus p squared plus q. These two are my vertex, and this is my axis of symmetry. So I'm going to put this equation, which is in general form, into a standard form. It looks like this to answer these two questions. So I'm going to try factoring it first, because if I can, it makes life easier. So y is equal to, now I got an x here, so x goes here, squared. 1, numbers give me 1, or 1 times 1. Can I get 6 out of that? No. So I can't do that. So I'm going to have to complete the square. So y is equal to x squared plus 6x plus 1. Put a bracket around here because I'm only going to want to worry about those ones for now. So y is equal to x squared. I'm going to divide that by 2. When I get 3 plus 6x, and 3 times 3 is plus 9. Because it's not part of the equation, I also take it out. Plus 1. Because 9 minus 9 is 0, and it still makes the equation the same. I then rewrite it, and I take this one out of the brackets, minus 1. If I factor this, I can see that y is equal to x plus 3 times x plus 3, and if I combine these two, I get minus 8. These are the same. I'm just going to rewrite it up here. So y is equal to x plus 3 squared minus 8. This looks like that, which tells me that for minus p to go to plus 3, that's got to be negative 3. And for plus q to go to minus something, it's got to be negative 8. So there's my vertex. We also said that the x is my axis of symmetry, so negative 3 is my axis of symmetry. It should be written as x is equal to negative 3. These answers are the same as that. So there we go. Now take a look at this one, because this one deals with fractions, okay, and getting rid of the coefficient with the x squared. It's a little more difficult, but it can be done. So take a look at it. Once you've taken a look at it, I then want you to stop the tape, try the question. Once you get in trouble, then turn the tape back on, and we'll go from there to show you how I answered it. So here we go. So we're going to put this in standard form because we want to find the vertex and axis of symmetry. So y is equal to negative 4x squared plus 9x minus 2. I need this to be by itself. So y is equal to negative 4x squared minus 9 over 4x bracket minus 2. I'm now going to divide this by 2. So y is equal to negative 4x squared minus 9 over 8x minus 2. So dividing it by 2, I just multiply the 4 by 2. I then will now square this. So y is equal to x 4x, x squared, minus 9 over 8x plus 81 over 64 minus 81 over 64 in brackets minus 2. Remember, this is not part of the equation. That's why when it's added in, it's also taken out. I do not want this one, so I'm going to throw it out. But as I throw it out, because it's inside the brackets, that 4 has to multiply it. So negative 4x squared minus 9 over 8x plus 81 over 64. Negative 4 is going to times that, equals plus 324 over 64 minus 2. Y is equal to negative 4 x squared, and I'm going to just go, or get rid of that x squared, minus 9 8x squared. So that just stays, that just comes down. Now I'm dealing with these numbers outside. Excuse me. So once you factor, once you get the different completing of the square, you can just take this number and put it back in, and you're good to go. These, because they're fractions and whole numbers, I have to find a common denominator add them. So y is equal to negative 4 x minus 9 8 squared plus 324 over 64 minus 128 over 64, because it's got imaginary 1, so 1 times 64 is 64, 2 times 64 is 128. I'm going to minus them. So y is equal to negative 4 x minus 9 8 squared plus 196 over 64. So there's my vertex. Vertex is 9 over 8 and 196 over 64. It stays positive because there's a negative sign there, and in the original equation, or the equation we look at, this is negative there, so it doesn't change, which is a positive number, replaces the p. Axis of symmetry. Sorry. X is equal to 9 over 8. So there's my equation solved. A little more difficult because it's fractions, but it can be done. Just take your time and follow the steps. Then take a look at your assignment in the calendar